Hello everyone, welcome back to my YouTube channel. This is Sandeep Kumar from Sri Venkateshwara College of Engineering. And this is the today's topic is VLSI design on UART is a universal asynchronous receiver and transmitter. And introduction to the UART and UART stands for Universal Asynchronous Receiver Transmitter. It is a hardware communication protocol used to asynchronous chronous serial communication, and UART facilitates the transmission and the reception of serial data between the devices. And some importance of UART in the VLSI design is UART is widely used in the communication in an embedded system. It is essential for connecting microcontrollers, sensors, and the communication models, and understanding UART is crucial for designing efficient in the VLSI system. And the basic operations of UART are UART operates by transmitting data in the serial of bits, and data is sent in the frames consisting of start bits and data bits, priority bits, and stop bits. And the asynchronous nature allows the device to communicate without a shared clock. And UART frame structure is a typically UART frames consisting of one start bit and 5 to 9 data bits, and optional priority bits, and one more stop bit. And the start bit signal it begins beginning of data transmission, and the stop bit indicates the end of the data frames and provides a pause for the receiver. And this is the small structure of the UART frame is start one is the first one is the start bit, and some 5 to 9 bits are data or message bits, and the last one is stop bit. And coming to the VLSI design consideration, and VLSI design of UART must be considered timing, power consumption, and the area. Ensuring reliable communication requires careful design of signal integrity. A designer must balance performance without manufacturing contracts. And these are some key components of UART. And the main component of UART includes the transmitter and the receiver and controlling logic. The transmitter converts the parallel data to the serial data for transmission, and the receiver performs the reverse operation, converting the serial data back to the parallel format. And this is the small circuit diagram for transmitter and the receiver is consisting of some circuit designs. And coming to the transmitter design, is the transmitter design include shift registers to convert the parallel data into the serial forms. It generates the necessary timing signal for sending the data bits. The design must ensure the data is transmitted at the correct baud rate. And the coming to the receiver side, receiver design, the receiver capture incoming serial data and the shift into the register. It must synchronize with the start bit to the accurately reconstruct the data frame, and the error detection mechanism like priority checking, enhancing data integrity. And this is the baud rate generation, and the baud rate determines how fast data is transmitted over the UART. And the baud rate generator creates the clock signal for transmitter and receiver. And the common baud rate includes 9600 and 152 115200, and higher depending on the application needs. And this is the data, small data on transmission speed and the real transmission speed, and the broads including broad column and bits and the bit duration and the speed. In case of 50 bd, the bit per second is to be transmitted speed is 50 bits, and the Bit duration is 20 milliseconds, and the speed is 6.25 byte per second. These are small data of consisting examples for the transmission speed and the real transmission speed. And coming to the asynchronous communications allows device to operate independently without a clock line, and the timing synchronous is achieved through the start and stop bits. This feature simplifies the wiring and reducing the needs for the additional components. This is the power management in the UART. The power consumption is crucial factor in the VLSI design for battery operated devices. Implementing a sleep mode can be significantly reduce power usage during idle times, and the efficient power management enhance the overall performance of UART system. Is some diagram on circuit design, timing simulation, and the physical design role checking. And this is some error detection and the correction in the VLSI design on UART. Is error detection methods like priority bits and checksums are vital in the UART communication. These some methods helps to identify and correct errors that may occur during the data transmission, and implementing the robust error handling, increasing the reliability of UART interface. And this is the testing and the verification process. Is testing is essential to verify the functionality of UART design. Simulation tools assist them in identifying timing issues and the functional errors, and the time testing ensures the UART meets performance specifications and the reliable standards. And this is the diagram on verification and the testing. And the verification consisting of coding, system design, and system requirement and the business requirement. And coming to the application of UART in the VLSI, and the UART is commonly used in the GPS models, Bluetooth the device, and the microcontroller interfaces. It facilitates communication between the computers and the peripheral devices, and it is versatility makes it suitable for wide range of applications in the customers electronics. And these are the some future trends in the URT designs. Or the future advancements may include improved data rates and enhanced error correction techniques, and the integration of URT with other communication protocol can be enhanced functionality. Continuously innovation in the VLSI design will be leads more efficient and compact URT solution. This presentation provides comparisons overall of UART and its significant in the VLSI design, covering fundamental concepts, design consideration, and its application. And thank you for